Hello and welcome to this IMechE webinar. My name is Howard Warriner and I'm on the IMechE's Warwickshire area committee within the Midland region. Today, greatly assisted by Emma Pateman from IMechE's head office in London but working from home, we're pleased to bring you a presentation on the Dennis Eagle eCollect, an electric refuse collection vehicle, or RCV. This is presented by Andy Graves, Dennis Eagle's Product Marketing Manager, Chassis. All being well, we'll have time for a question and answer session. I'll be looking at your questions as we go along, and if you're watching the live broadcast through webcast, then you can use the Ask a Question button on the overview panel. Andy joined the waste vehicle manufacturing industry in 1972 with Shelvoke and Drury, moving to Dennis Eagle in 1991. He's been involved with the product development process from design, development and production through to sales and marketing for refuse collection vehicles and specialist HGV chassis. Like me, he's both a keen cyclist and a green advocate. Over to you, Andy.
Thank you, Howard. Hello and welcome to our eCollect webinar. Hopefully you can all see the screen properly. And what I'm going to do is give a brief history and overview of our company. We have a heritage going back to the 19th century. And for example, here we show a 1902 Dennis car and our eCollect from 2018. This is when we first had our development vehicle built. The Dennis brothers started their business in Guildford in 1895, producing bicycles, mowers, progressing on to trucks, buses, fire engines, and they also at one time, of course, produced cars. But with keen business minds, the Dennis brothers decided to target their efforts on niche markets, and of course the municipal and bus and fire industries fitted nicely into that category. And really it was the core product and still remains the core product, although Dennis is now Alexander Dennis at Guildford. We're now completely separate companies. Eagle Engineering began around 1907 in Warwick, and they were brought together by the Hester Group in the 1970s. And the factory that we occupy now was actually opened in 1985 as a greenfield site. And you can see a few milestones there. In 1992, we launched the Elite low entry cab. And of course, we're famous for refuse bodies. But in 2009, we introduced the smooth-sided Olympus body. We've had several owners over the years, including Ross Rocker, the Spanish company. We've been owned by ABN AMRO, the Dutch bank, NatWest Equity Partners. But in 2016, the Turbo Group took over the majority holding for the company and the group. So now we're part of the environmental equipment division of the Turbo Rocker Group, and we have manufacturing sites in Germany, the Netherlands, Spain, and of course in the UK. But we also have sales organisations across Europe and around the world. Here's a short video just to give you an idea of some of our production processes and just what we do at Dennis Eagle. So that gives you an idea of our production processes, and of course we use a lot of the same principle as the car manufacturers in automotive, the body in white principle and so on. But of course the size of our products means that our production lines aren't automated in the way that they are for cars. Now we're going to set the scene with a brief section on the challenges that we've faced with this project, some of our previous projects for alternative fuels, and then our solution, the eCollect product. Then hopefully there will be time for a Q&A session at the end. Transport is a big contributor to global warming, and with heavy vehicles having the biggest impact. So we felt we needed to help reduce that impact in any way we can. When you also consider that a distribution truck can average over 9 miles per gallon when travelling on motorways, but a refuse collection vehicle, when collecting waste, may only achieve around 3 to 4 miles per gallon, with constant stop-starts and a repeated use of compaction and lifting equipment. So the refuse collection vehicle is a key target for change. Of course, traffic plays a major part in air pollution, and it also concentrates the pollution where we least want it, in cities and towns. And in a recent poll, 83% of Londoners thought that tackling air pollution should be a priority. And of course, when that public opinion is that strong, then the politicians start to act. And of course, we've already seen the clean air zone in London, but it is now starting to spread across the country and also across a lot of other cities around the world. There's currently debate about Leeds, what they're going to be doing, but Oxford and Cambridge already have air quality problems, Manchester, Birmingham. So we expect to see many more cities starting to introduce charging zones and so on. Since the 1990s, Dennis Eagle had developed alternative fuel vehicles. For example, in the 1990s, CNG and LNG systems, though there were problems with infrastructure and the quality of the fuel. We progressed on to dual fuel systems where CNG would be injected into a diesel engine, but they proved to be less efficient with a refuse vehicle than with a distribution vehicle. We've also experimented with electric bodies, and in 2014 we launched a range extender hybrid, the vehicle you can see, our high urban collection vehicle. But really that was a concept vehicle, and that was to help prove some of the concepts, and that was with Myra, Hariba Myra, and with other partners, and it was to progress some of the development ideas that had been building up over the years. But within our group, we also have a lot of experience with the terminal tractors, with electric bin lifts, with EPTOs, and we're starting to learn more about autonomous vehicles. And we have over 30 of the electric terminal tractors in use around Europe. So a lot of the concepts that were already in use for that type of vehicle have been carried over to our product. So we've tried and discarded several alternative fuel options, but the electric refuse collection vehicle, or eRCV, was a natural choice for us as the way forward. At Dennis Eagle, our remit was to produce a vehicle with reduced carbon emissions and, of course, reduced air pollution, but it also had to be cost effective and a genuine alternative to diesel vehicles. And Dennis Eagle, as far as we know, are the only original equipment manufacturer to design and build a complete refuse collection vehicle that includes the chassis, the body, the cab and the bin lift, which means that we manufacture complete. It's not just a conversion of a traditional distribution vehicle. The eCollect was based on several important design principles. The first was that we would change as little as possible by using our existing chassis, bodies and lifters. They're already tried and tested, hugely popular, and of course familiar to the drivers and crews, the service and maintenance people and our users in general. And they're considered a benchmark for safety. And for eCollect, we decided that we also wanted to carry over the cab design, which an independent assessment for Transport for London has concluded that it provides the safest, the best direct vision for drivers of any truck in the UK. And it is fully 5-star rated. Dennis Eagle worked with Transport for London from around 2015 to help promote the standard. But we've also provided vehicles and worked with Loughborough University, where they've scanned and used 3D CAD data to provide the benchmarking for the system. Now, of course, we offer the benefit of a one-stop shop, so the customer can come to us for chassis, body. We also provide service, repair and maintenance. But also it means that the vehicle is fully tested as a complete entity. It has full European whole vehicle type approval. It has all of the EC safety and regulation norms and directives all covered within our testing and approvals. And it means for the end user, it is a safe and reliable product that he can rely on. Again, a cornerstone of the design was that the eCollect had to be a genuine alternative to our core product. Our best-selling vehicle is a 26-tonne narrow vehicle with a 19 cubic metre body. So we've used that as the basis for the electric vehicle. We've also used an automatic split bin lift, which probably 80 or 90% of our users now employ. And we wanted to maintain a genuine 10-tonne average legal payload on the vehicle. Early electric refuse vehicles lacked the battery power to allow a full day's work. And there were also severe limitations on the charging infrastructure and the range of the vehicles. But battery chemistry has improved, there's better power density, better stability, and with a significantly increased energy density, the batteries can be smaller and lighter, which means that they're operationally viable. The latest development uses the lithium, nickel, cobalt and manganese chemistry, very similar to that used in a Nissan Leaf, for example. And it meant that we were able to ensure that we could get the lifespan of the vehicles and also provide the operational performance that our customers require. To optimise performance, we first had to do data logging to check the duty cycle. So we've checked lots of different operating methods, different terrains, and we obviously need to check on the auxiliary power consumption. Is not only the compaction and moving the vehicle, but we've got the brakes, the steering, and so on that had to be factored in to make sure that the power pack effectively was going to be adequate for operation. And of course, we still continue to monitor performance on the vehicles that are now out in the field. So we had a clear target to provide zero vehicle emissions, and there are several benefits which make it a compelling argument for its use. Electricity is much cheaper and has a much more stable price in the market compared to the carbon oil-based fuels, and generally it costs less than half as much to travel the same distance with an electric vehicle than it does a conventional diesel vehicle, and the electricity infrastructure is improving day by day within the UK. So once we'd decided to commit to the project, we had to select a configuration, and with the extended data logging, we knew the sort of power levels we were looking for, and we obviously had to test locally and at proving grounds to make sure that we got our sums right. So we've used 5 60 kilowatt hour battery packs, giving a total of 300 kilowatt hour, a 200 kilowatt hour motor, which provides power through a reduction gearbox and a traditional prop shaft and differential to the drive axle. We've made minimal changes to the chassis using a conventional layout with Euro 6 standard proven braking, suspension and steering systems. The diesel engine, gearbox and after treatment obviously are taken away from the vehicle and are replaced with that electric motor, the batteries and control system. But the chassis components and systems are already familiar to engineers, technicians, ready for use. So as I said, we've got 5 battery packs on the vehicle. One sits under the cab where the engine would normally sit, and then 2 each side. They weigh nearly 400 kilograms each. And at 26 tonnes, we can still obtain over a 10-tonne legal payload, but we are hoping for a 27-tonne operating derogation for the vehicle, which allows for the additional weight of the batteries and controller and installation. We also decided that the vehicle would be aimed initially at urban rounds, where the distances travelled were typically shorter. This would ensure operation of the vehicle was viable, but it also delivers the benefits of zero air pollution where it matters most. And on the basis that it's an urban vehicle, we chose a narrow chassis and a rear steer configuration for best manoeuvrability. The heart of the electric vehicle is the power controller, which monitors and controls the battery packs, acceleration, braking, and the auxiliary systems. But to the driver, it feels like a normal truck, albeit with a little bit of extra acceleration. We have had to limit the top speed of the vehicle at the moment to 40 miles an hour, though we are looking at a 2-speed gearbox to introduce hopefully later this year. But even though the vehicle's limited to 40 miles per hour, we have found that against most traditional diesel vehicles, you can still finish the collection round around 20 to 30 minutes earlier because of that improved acceleration. There are a few changes within the cab, but to the driver, most of the controls are very familiar. We have a new instrument cluster, new gear change pad, and new programmable switches. And the fuel gauge, of course, is replaced by a state of charge display. And we have a simple bar graphic to show the percentage of battery charge. We also have a warning, a tortoise warning, as we call it, for return to base, with an amber warning at 15% state of charge and a 7% warning in red to let the driver know he really does need to return to base. But generally, we've been able to do 2 collection rounds a day, collect over 10 tonnes on each collection round, and still have around 17 to 20% state of charge at the end of the day. I'm now going to show a short video. I'm not sure if you'll hear the sound, but you'll hear that it is much quieter than the diesel vehicle if the sound is working. So you may have heard a warning beep to let you know that it's going through a test startup sequence, and then there's a gentle hum when the vehicle is ready to use. And you can see the state of charge bar graphic on the right near the speedo. For charging, we use an industry standard CCS2 charger. We need 4 15 volts, 3-phase AC, 63 amps preferred, and a nominal 50 kilowatt hour rating. Generally though, the charger will work between 25 and 40 kilowatts to actually charge the vehicle, and it is a smart charger that we use, and it is an off-board charger. Now, of course, it is simpler to service the vehicle. There are fewer consumable parts, no engine oil changes, no fuel filter or DPF changes or cleaning. But it does need additional training for the high voltage systems. The vehicle runs at 600 volts, but we provide our normal lifetime support. We have a service support network where we're training our technicians and mobile engineers on the use of the high voltage systems. We have a fully illustrated electronic parts catalogue, and of course we also offer the normal repair and maintenance contract support. And to ensure safe working, we have a vehicle safety equipment kit that we can offer, and that includes the PPE equipment, but also a defibrillator and also an insulated hook in case anyone ever were to be electrocuted, because of course with voltage at that level, it is important that you do remain insulated if you do have to pull anyone away from the power source. We also have telematics on the vehicle. The EV systems have their own telematics, and then we have a general vehicle telematics system which can monitor vehicle health, provide diagnostics and warnings, and also under development we have systems where it will give battery state of charge and the condition of the battery and control system. The warranty is 3 years as standard, but we do have extended options available. But we use the same procedures as for the standard diesel vehicles. So to our customers, there's no real difference in the way we handle requests or call outs for the vehicle. And of course, we've designed in safety from bumper to bumper. The body, the bin lift, the chassis, they're all fully compliant with safety and type approval regulations, but we also add other features. So for example, camera systems with an optional DV recording system, and that also can be linked to the eCollect telematics, so you can have live view of what's happening around the vehicle, and also reporting for insurance purposes and so on. So of course, the big question, why switch to an electric RCV? I can see several questions popping up, and quite a few of those questions are going to be covered as we carry on through the presentation. The eCollect is a true zero emission vehicle, and of course with a sustainable power source can make a real difference to the environment. There are competitor vehicles in the marketplace, but the eCollect is the only truly integrated refuse collection vehicle, and it is purpose built for waste operations. So reference the earlier points on the traffic and cities. We've chosen to focus on a narrow track vehicle which helps to ease traffic congestion. It's 30 centimetres narrower than a traditional HGV, so that helps promote free-flowing traffic. And of course, cleaner vehicles and less congestion means a cleaner environment. With no tailpipe emissions, the eCollect really does have zero impact on the environment when collecting waste. And of course, it does mean there is a lot less noise. You may have seen the Eunomia 2020 report, Ditching Diesel. Our findings marry up with theirs, where they find it's much quieter when idling, half as loud when packing, though of course you do still have the sound of whatever waste is going into the hopper, that remains unchanged. But it is much quieter to work around, much more comfortable for the driver and crew. There is less maintenance, fewer moving parts. The electric motor is a brushless motor. And as I mentioned before, there's no exhaust muffler, no diesel particulate filter, no AdBlue. And it does have better acceleration. There's almost instant throttle response. And we have found it does result in shorter route times and a more relaxed driving experience. We've been asked about power consumption, and of course the duty cycle per round can vary greatly. but we show some sample data here from typical collections. This was around the Leamington Spa and Warwick area, collecting domestic waste. We covered over 66 miles over 2 collections, collected over 20 tonnes over the day, and we still had 29% state of charge at the end of the day. We've also carried out double shift testing over quite a few different areas. This was in the London area, where we covered over 85 miles. It was with lighter material. It was with recyclables on the first round and glass and bottles on the second round. But we still had over 17% state of charge at the end of the day. And of course, we're continuing to carry out duty cycle analysis with data logging on a regular basis. And that's partly to ensure that our assumptions have been valid, but also as a basis for any updates we do and to optimize the vehicle as we continue with the development process. We've now over 20 orders going through build at the moment, and we expect to be building between 2 and 4 per week, whereas for traditional diesel vehicles, we're producing around 26 vehicles a week. So, now time for more of those questions.
Thanks very much, Andy. Yeah, you've seen the questions coming in.
Yeah.
So I've got a few of them lined up for you. So we've got plenty of time for those. So if you're watching, watching the live broadcast, then keep them coming, and we'll try and get some more in after we've got through the first batch.
Right.
So the first question that came in, and there's a later one as well, related to hydrogen. So somebody early on asking about hydrogen as a fuel, and somebody else later about fuel cells, which I guess would be basically hydrogen, and whether they might be longer range and possibly lighter as a vehicle.
Well,
has that been considered?
I'll answer that question first. We have looked at hydrogen fuel cells, and we have talked to a few suppliers of equipment. At the moment, we feel that the costs and the weight penalties rule it out at the moment, and there's also the problem of actually finding these fuel supply. The infrastructure is not really there across the country at the moment. There are a few key areas like Scotland, of course, where it is a bit more readily available. But we're waiting to see what happens. So probably for the next 2 or 3 years, we're just going to stick with the electric vehicle, but we are keeping tabs on what's happening with the fuel cells. And of course, the cost at the moment is quite prohibitive for heavy vehicles, for those fuel cell systems. I'll ask you the one about how the battery packs perform in sub-zero temperatures. Below about 5 degrees Celsius, there is a degradation of battery performance, but of course in the UK that doesn't tend to be a general problem, but it does have to be factored in by the customers.
There's also a question about maximum temperatures as well. You know, what is there a maximum?
Well, it's with a diesel engine, you would normally work to certain zones, and we expect to operate, certainly in Europe, to around 45 degrees generally without any problems. Once you get into the area of about 50 degrees, there could be an issue. But at the moment, we're intending to stick to UK and Europe, so we don't see that as being an issue.
Okay, right. And somebody was asking whether you'd be able to tell us who's supplying the batteries.
At the moment, they're supplied through Magtech, who also supply our electric motor, and they've done lots of work with buses and other systems. But of course, they are effectively the same type of batteries as used in a Nissan Leaf. But Nissan Renault, for example, are already looking at a new generation of battery. So it may be over the next year or two, we will also be looking at further developments. But they're a well-proven battery, good power density, and we see that they have a good anticipated life. So certainly for the moment, we're going to stick with that well-proven battery.
Thanks. Yeah, and you mentioned a couple of the test runs you've done for proving the range of the vehicle. And there was a question on what infrastructure would be used to charge it up. So I guess it would be going back to a depot typically, wouldn't it? So
generally it will be going back to a depot. There are a few CCS2 chargers of a substantial power rating. For example, some of the motorway services have them, but I suspect electric car drivers won't be too pleased if a refuse vehicle was to turn up there and block all of the other charging stations, because this vehicle in particular is just over 10 metres long. So it really is a depot operation that's best for it.
Okay. Yeah, some questions around the operation. Again, thinking about different temperature, different weather conditions really. So in terms of heating and cooling the cab, and whether that would affect the range significantly.
We have a heater system and an optional air conditioning system that we can offer. But the air conditioning, for example, consumes about 5 kilowatt hour. So that certainly will have an impact. But in the UK and Northern Europe, generally, you would use the air conditioning first thing in the morning, and then the heater system may be okay, but it's really only in Southern Europe that you might want the air conditioning all the time. But it certainly will have an impact. Sorry, say again.
Somebody's asking whether you could put solar panels on it to get a bit of extra power.
That's certainly a possibility. Most of our customers in the UK don't even specify air conditioning, so we feel that the heater for most customers, the HVAC system, will be okay as is. But yes, we might need to start looking at supplementary power supply if they do want to have air conditioning on all the time. Shall I go through the questions to see what other ones are there?
I'm trying to keep on top of them. So yeah, somebody was asking, there's a difference in the level of vibration. It'd be as you say, smoother drive with the electric motor. So is there any sort of design scope for optimization of the chassis, given that the level of vibration is that much lower? Maybe a bit of weight reduction.
Well, the vehicle actually is heavier than the traditional diesel vehicles.
Sure.
I would say generally about 1,000 to 1,200 kilos heavier. But the performance of the motor, there's much more torque to begin with, of course. But it does feel a smoother ride. Now, we only use an Allison automatic transmission anyway in our vehicles, which does provide a smooth ride. But of course, you can detect the shift from one gear to another in the automatic transmission. You don't have that with the electric vehicle, so it is a much smoother ride anyway.
So yeah, somebody else asking about all-wheel steering. I saw that it does have rear steer, doesn't it? But
it just has rear steer. With the concept vehicle we did in 2014, that had a steering drive axle, but we've decided that the additional cost of that doesn't really give any major benefits for most users. So that remains on the shelf just in case it's needed in the future. But we have a standard fixed drive axle with this vehicle.
Yeah, right. And somebody else is asking whether how you decide between just having one single motor or perhaps in-wheel motors or several, or more than one.
Well, again, we're aware of hub motors, if you'd like to call them that are in development, and that concept vehicle had that type of arrangement. but the costs at the moment outweigh the benefits. So until we find a suitable alternative at a good price, we'll be sticking with the current system.
Something I've wondered actually is, I'm not sure if you mentioned whether it had regenerative braking.
It does have regenerative braking, and of course it depends on the terrain and the duty cycle, but at the moment we believe that we're boosting the power by about 15% through the day through that energy recovery. There's a question about the lifetime. We expect the batteries to last the life of the vehicle. Most of our customers expect the vehicle to last at least 7 to 8 years. Many will operate to 10 or 15 years, particularly some of the private contractors. But there is a second life for the batteries. There are already companies, Zenobē is one for example, where they're talking about providing a transport container, a 40-foot container filled with batteries where you can charge it off-peak and use it to charge the vehicles, which also means there's less dependence on the grid if you've got a large number of vehicles. And for the second life of the batteries, you could use them in that type of application or for schools or hospitals as emergency power.
Mm-hmm. There's several questions around cost, so people are understanding it would be more expensive to purchase, but cheaper to run. So
it is.
Do you have a sort of figure on?
Yeah, it's over double the cost of a traditional diesel vehicle. If you said a fully spec'd diesel vehicle would be around £210,000, you're probably talking about £430,000 for a fully spec'd vehicle.
Yeah, somebody asking about the battery packs getting heated up, possibly overheating in summer. Is that?
Well, with all the testing we've done, we've not really had any problems. No. And we've done a lot of testing at Millbrook and Myra, and also field trials as well. We've recently had the vehicle in South Wales, where it's worked in the Cardiff and Newport regions, Merthyr Tydfil, Rhondda, Cynon Taf, where there are some quite hilly areas, and it's not really caused any problems. And of course has included working at fairly high temperatures, 35, 36 degrees, without any real problems.
Right, yeah, there's another question actually. Is there a maximum incline that it can cope with?
Well, at Millbrook we used a 14% incline, fully loaded. It was actually loaded to over 27 tonnes, and that moved off without any problems. That's from a standstill. I think it was a 22% gradient in the Merthyr area. The vehicle went up there at 30 miles an hour. It was obviously already moving when it started on the hill without any problems. So we don't see any major issues, but a 1 in 4 gradient could be an issue, but that could be an issue with many other vehicles as well.
How long does it take to recharge? Did you mention that before?
From a 15% state of charge, it takes about 7 to 8 hours to charge with a 50 kilowatt rated charger. Mm-hmm. And of course we recommend that you don't allow the batteries to go down to 0%, but that's the purpose of having that return to base warning. Somebody's asked the minimum data size required to properly estimate the duty cycle performance. Generally, we'll data log a vehicle for a couple of weeks because you can often find that a vehicle won't be working the same route or the same type of collection on a daily basis. So we like to gather data over at least a couple of weeks to be able to determine the power requirements for a particular area. And again, really it's aimed at urban collections, particularly with the 40 mile an hour speed limit at the moment. The dual carriageways and motorways, it's a bit of a no-no, but for short distances, you know, where we've worked in the Warwick and Leamington area, we've had to drive to Coventry to discharge the load, and that has been without any real problems, and of course it's still finished earlier than the traditional vehicle would have worked.
Mm-hmm. And then there's a question on actually using a similar setup in alternative industries. Are there plans, or is it possible to use the same chassis?
It is possible, but at the moment we're concentrating on this integrated refuse vehicle. It will probably be a year or two before we decide to release it for other applications. But there are similar applications like for road sweepers, for tanker use and so on, where traditionally we've supplied chassis that would be a natural fit for this type of vehicle. But as I say, it will be a couple of years probably before we start offering chassis for that type of use.
Okay, thanks. Yeah, we've still got a few minutes. People have got any last questions? I've tried to cover as many as I can cope with while talking and listening and doing at the same time. Just had a couple that I'd prepared beforehand. I wondered, you mentioned that you worked with Loughborough University.
Yeah.
I wondered how that worked and whether you had a contact there already, or whether you sort of looked at several universities and picked them.
Well, that was actually for the direct vision standard. So we've not worked with them on the electric vehicles, but in the past we've worked with Warwick Manufacturing Group, Warwick University and the PARD Group on alternative fuels, dual fuels, and a lot of the work we did with them on understanding the power consumption has worked towards this, and that goes back to probably about 2006.
Okay, thanks.
There's a question about the comparison with diesel consumption, cost and energy. The Energy Savings Trust have done quite a bit of work, and the electric vehicle does tend to be much more efficient in terms of the use of the energy, around 30% that compared to diesel. But of course our application is quite a high consumption compared to most vehicles. You're talking about a litre of diesel per kilometre travelled. But we've sized it more on the collection requirement, which is why we ended up with a 300 kilowatt hour energy capacity. And we'd expect over the day that you would consume around 250 kilowatt hours and still have a safety margin to get back home.
Mm-hmm. Yeah.
Electric fluid pumps, we use a two-stage hydraulic pump with reduced cartridge size, because of course the electric motor's running at a higher speed than a traditional engine or gearbox PTO. But effectively they are standard Denison hydraulic pumps that we use. The power steering of course is driven electrically. The brake compressor is driven electrically. But we try and keep the systems as standard as possible in comparison to the diesel systems.
Yeah. There's been some talk about using electric cars, and I guess potentially this vehicle as well, as a form of energy storage. Is that something you considered in the development process? So actually, while it's charging, maybe actually discharging if there's a sudden demand on the grid?
Well, there is talk of going vehicle to grid, and we're aware of systems across Europe that are doing that, but we're also aware there have been problems, for example, where a local authority depot is sited next to a recycling plant and they use a lot of the machinery in the plant at night, where it can detract from the power supply needed for the vehicles. So that is something on the agenda for future development, but at the moment our vehicle is not going to provide vehicle to grid power back.
Okay.
as such.
Okay.
We have considered capacitors. I see that's another question.
Yeah, I missed that.
But again, a lot of those systems are aimed more at the smaller vehicles. Certainly we wouldn't poo-poo the idea, if that's the right phrase. We wouldn't turn away from developments like that. And also the photovoltaic cells, solar cells, they've certainly got their place. But really it's the infrastructure and power suppliers who would need to be involved in those sort of systems. Our technical development centre is in the UK, but we can call on our colleagues in Spain, Germany, France and the Netherlands for assistance. But we have our own team of design and development engineers here at Warwick. I see someone from Cummins is asking about sharing the slides. They will be available, and I believe this is recorded. The webinar will be available through IMechE.
Yeah, the IMechE webinar page, and also it should be available through YouTube as well in due course, like in a week or so.
Total cost of ownership, that's hard to say because it depends so much on the routes the vehicles are working, but again, we expect over 7 or 8 years that it will be a break even. And of course, it's the fuel versus charging costs that can make quite a big difference.
So we're having a good look through. I think I've covered, or tried to cover most of the questions as they came in.
Yeah.
So if there's any more that catch your eye.
Yeah. Now, there is a question about the fluid pumps for battery temperature. At the moment, the batteries don't have a coolant system. We are familiar with other vehicles that do have that, but we do have cooling for the control system.
Okay.
In terms of cradle-to-grave CO2 benefit, there has been analysis done, but again, we would expect experts like the Energy Savings Trust, Low Carbon Vehicle Partnership to be an independent assessment, to be much better a source of information for like that.
Yeah, and there's a question on what percentage of energy is used to charge the batteries. I guess that depends what's going on the grid, doesn't it?
Yeah.
Increasing amount of renewable energy these days.
Yeah. There is a question about recovery of the vehicle. Like our traditional vehicles with the Allison gearbox, the automatic gearbox, you do need to disconnect the prop shaft before you tow the vehicle. You can isolate the truck battery system, the traditional truck electrics, which then in turn isolates the high voltage system, but you certainly shouldn't try and tow the vehicle with the prop shaft connected, because of course that can have an effect on the electric motor. It will work like a generator. I'm just looking at some of the other questions.
Well, yeah, call things to a close shortly, but yeah, if there's another one that...
Yeah, we do have regenerative braking, so there is energy recovery there. There's a question about public safety risk from the quieter running. Certainly, when you're driving the truck in traffic, it is quieter, of course, than most other trucks, but there is tyre noise, there is noise from the vehicle. It sounds like a milk float on steroids, perhaps. But there is adequate noise there that most people will notice it. But if people have headphones on, we do need to be careful, and we are actually testing over the next week or two at Millbrook or Myra to see what the minimum noise level is, because there is talk of having a white noise generator to ensure that there is adequate noise to warn people of its whereabouts. So we're waiting for the outcome of those tests, and there is talk of it becoming part of legislation for heavy electric vehicles anyway. So we may have to fit some additional noise generation to let people know the vehicle is about.
Okay, interesting. Yeah, thanks. I think we'll call it a close there. Thanks, Andy. So on behalf of the IMechE and all those who have joined this webinar, thank you very much for your presentation and for answering all the questions so thoroughly. And we wish you and Dennis Eagle all the best for the future.
Okay.
As we said in our publicity, we hope we may be able to bring you a further presentation, perhaps giving a bit more detail on the testing and approval process for these multi-function machines. So look out for that. We'll be working on that with Andy going forward. Thanks again to Emma Pateman and colleagues at IMechE in London. And finally, I'd also like to extend thanks to Professor Reza Zirati, whose Coventry and Warwickshire Air Quality Conference in July 2020 informed me about both Dennis Eagle's presence in Warwick and their electric refuse collection vehicle product. I thank you all for joining this IMechE webinar and enjoy the rest of your day.
Okay, can I just mention, Howard, that I have put the website address there for the eCollect, and that does include some video and frequently asked questions and so on. So
yeah.
Your viewers are welcome to have a look on our website.
Yeah, good point. Yeah, thanks, Andy.
Okay, thank you. Bye-bye.
Right.